So today we're learning about systems of equations and two variables. First of all, a system of equations is just a collection of two or more equations considered simultaneously. That just means you work them at the same time. There are many ways to solve a system of equations, but in this section we're only going to talk about three ways. One is by graphing, one is by substitution, and one is by using addition, or some people call it elimination. So let's try this by graphing first. Before we begin, we need to put the equations in a form where we can actually graph them. So if you look at the first one, we have x plus 2y equals 6. I want to put it in slope-intercept form. So, and you don't even have to do that. You could find x and y intercepts and graph it that way. It just seems like most people like slope-intercept form the best. So we're going to subtract x from both sides, and we'll get 2y is equal to negative x plus 6. Divide both sides by 2. So we get y is equal to negative 1/2 x plus 3. So to graph this, you're going to go up to 3. Then you're going to go down 1 over 2. Down 1 over 2. Down 1 over 2. You'll just continue to do that, and then you connect all of those points. So your first line would look something like this. Now whenever you solve a system by graphing, that's not exactly straight. Whenever you solve a system by graphing, you do want to be as exact as you possibly can. So using a ruler is a really good idea. Now this program is not letting me line these up exactly where it needs to go, so hopefully it'll work whenever we draw the second line. Alright, so for the second one, we have 2x minus y equals negative 8. We're going to subtract 2x from both sides, and then divide everything by negative 1. So we're going to go up 8, so that's 3, 4, 5, 6, 7, 8, up 8, and then we're going to go up 2 over 1. Up 2 over 1. You could even go down 2 and back 1, just if you wanted to get a few more points. That's actually a really good thing to do, because now we can see where those two lines meet, and that's actually what we're looking for. Okay, so here's the second line. Now the solution to a system of equations is the point where the two lines cross. In this case, our solution would be this point right here, whatever that point happens to be. So let's look at it. It's going to be 1, 2, so negative 2, 1, 2, 3, 4. So it looks like the solution is negative 2, 4. Now remember, the solution to a system of equations is a point. It's the point where they cross. So you do need to put these parentheses, otherwise it's just two numbers with a comma between them. Now to check this, you just take negative 2 for x, 4 for y, and substitute them back into both of these equations. If you put it into the first equation, you get negative 2 plus 2 times 4 equals 6. Well, 2 times 4 is 8. Negative 2 plus 8 is negative 6, so that one works. Now let's try the other one. 2 times negative 2 minus 4 equals negative 8. 2 times negative 2 is negative 4, and negative 4 minus 4 is negative 8. So that one also works. So that's how you solve a system by graphing. Now there are different types of systems of equations. One like the one we just did, where you get one solution. That means the two lines do cross, and they cross in one place. This type of system of equations is called consistent and independent. Now there's another type of consistent system, and that's this kind, where you graph one line, and when you graph the other line, it lies exactly on top of your first line. Consistent just means, that's down here, consistent just means that the equations have at least one point in common. So that's why these two are called consistent, because they have at least one point in common. This one is called independent because you have just one point that they have in common. This one is called dependent because every single point on the line is a point they have in common. So it has infinitely many solutions, and that's right here. This one has infinitely many solutions. Now what if you have parallel lines? That's a little bit different. Do these lines ever cross? If the lines never cross, then you have no solution to the system, and it's called inconsistent. So the difference, if they have at least one point in common, it's called consistent. But if they have no points in common, it's called inconsistent. Okay? Now let's keep going. So the next way we're going to learn to solve a system is by substitution. So the very first thing that you want to do is solve one equation for one variable. So I think this would probably be the easiest one. So we have 3x minus y equals 6. I'm going to solve it for y. So we'll subtract 3x from both sides and divide everything by negative 1. So we get y is equal to 3x minus 6. Now that we have one equation solved for one variable, we take that and substitute it back into the other equation. Okay? So we're going to have 6x plus, that's a plus by the way, 5 times 3x minus 6 is equal to negative 23. I know that you've noticed a lot of times my negatives disappear, so I'm going to just try to take a little time and make sure everything's still here. Okay, so we want to solve this for x, and we get 6x plus 15x minus 30 equals negative 23. I'm going to combine my like terms and add 30 at the same time. So we end up with 6 plus 15 would be 21x is equal to negative 23 plus 30 is going to be 7. Divide both sides by 21 and we get x is equal to 7 over 21 or 1/3. So right now we know that x is equal to 1/3. Now we take that and substitute it back into either equation. So I think it may be easiest just to substitute it into that first equation. So we have 3 times 1/3 minus y equals 6. 3 times 1/3 is 1. Subtract 1 from both sides. So negative y equals 5. Divide both sides by negative 1 and you get y is equal to negative 5. So your solution is this x that we got and this y that we got. So we have 1/3 negative 5. And you can check this one the same way by substituting 1/3 in for x, negative 5 in for y, and putting it into both equations. It must make both equations true. Let's try a couple more like that. If you want, you can pause the video, try to work them, and then turn the video back on. So, number 1, I want to solve one equation for one variable. I think I'll solve the first one for y again. So, subtract 3x, and then divide everything by negative 1. Then I want to take that, substitute it back into the other equation. Remember, you put it where the y is. So it's going to go there. And then we solve that. We'll get 6x minus 18 minus 6x equals 7. Well, what happens whenever we add 18 and combine like terms? This is 0. 6x minus 6x is also 0. And 7 plus 18 is 25. There are no more variables, right? That means there's nothing else we can do. And 0 is not equal to 25. That means these two lines are actually parallel. So there is no solution to the system. So this is what it would look like if you solved a system of equations that turned out to be parallel and you solved it using substitution. You would get a statement that's not true, like 0 equals 25. Alright, well let's try the other one. I think just to see what's going on, it may be easier to get rid of the fractions in the first one. So I think what I'll do is multiply by the least common denominator, which is going to be 6. So that'll give me 3x, 1/2 times 6. Then we do 2/3 times 6. 3 will go into 6 2 times. 2 times -2 is -4. And -2 times 6 is -12. Now we can go ahead and solve the second equation for y. That may be the easiest thing to do. So we just divide everything by 4. And we get y is equal to 3/4 x plus 3. We want to take all of this and substitute it in for y in the other equation. So we get 3x minus 4 times 3/4 x plus 3 equals -12. Now we want to solve. So 3x, if you do -4 times 3/4, you get -3. And -4 times 3 is -12. And this time, if you combine like terms, you get 0. So you just get -12 equals -12. Or you could even go even further, so add 12 to both sides and get 0 equals 0. Well, this is a true statement, and there are no more variables. That means these are the exact same line. And if that happens, then you have infinite solutions. Now you do need to learn how to write these infinite solutions as an ordered pair. So let's talk about how that works. If it says write your answer in terms of x, you know in your answer you have an x and a y, right? Well, if it says to write it in terms of x, then each one of these variables, these sections, need to have x's in them. Well, if I'm writing it in terms of x, then the first one's just going to be x. But for the second one, we need to write it with an x in it. So look back at your problem. Right here, we have y equals something with an x in it, right? That's what we write here. Since a y is equal to that, then what goes here would be 3/4 x plus 3. Because this is what y is equal to, but it needs to be written with an x in it. So this is how you would write that infinite solution. It's any x as long as the y that goes with it satisfies this condition. That's what that means. So the third way we're going to learn is by addition. Now this is a mathematician's favorite way to solve a system of equations. Let's look at the first one. If I were to just simply add these two equations together, what would happen? 3x plus 2x is 5x, negative y plus y is 0, and 9 plus 1 is 10. Divide by 5, and you already have x. Pretty cool, huh? Now you take this 2, and you substitute it back into either equation. Kind of like the second one just because the numbers are smaller. So I put the 2 in the place of x. 2 times 2 plus y equals 1. 4 plus y equals 1. Subtract 4 from both sides. And you get y is equal to -3. So your solution is going to be 2, -3.